Hello, I'm Hans Summers, Golf Zero Uniform Papa Lima. I'm going to introduce the new QCX transceiver kit from QRP Labs. Apologies in advance, this won't be a very professional video. It'll be only one take, there won't be any editing or any background music, and there may be mistakes, I may hesitate. Right, so this is a single band CW transceiver kit producing 5 watts of output. You can choose at the time of ordering your band from 80, 60, 40, 30, 20 or 17 meters. 90 people at the RSGB YOTA Summer Camp Buildathon at the beginning of August 2017 built this kit, the 17 meter version, and apparently enjoyed it greatly. So a little bit about the board itself. Firstly, the board that you get comes like this. It's a double-sided, through-hole plated PCB with silkscreen on top, very high quality. The only 2 components in the whole kit, which are surface mount devices, are already soldered by the factory, as you can see here. So for those of you who don't like soldering surface mount components, you don't need to worry. It's already done for you by the factory, and everything else that remains is all through-hole components. The board size is about 4 by 3 inches. Everything is all mounted on one board. This is how the kit comes, including the knobs here and the micro switch and all the connectors. The LCD display module unplugs like this, and underneath you can see the microcontroller here, which is socketed. All the other chips are not socketed. Of course, you could add your own sockets if you wish. Okay, so it's quite easy to build. The instruction manual is extremely comprehensive. You download the instruction manual from the website. It includes step-by-step instructions showing which components to install where on the board. Very, very detailed. It includes the operation manual describing each of the menu items, and later on you will find a section with a block diagram of the circuit and the full circuit diagram here, and an explanation of how it all works and why it all works. And right at the end of the book you will find some measurements that I made on my prototypes, which should give you some idea of what to expect. Finally, on the last page you will find what I call the cheat sheet, which gives you a very nice single-page reference for all the menu items and how to operate the radio. So that's it, very comprehensive instructions which already got quite a lot of nice feedback from people who have built the kit so far. So some words about the design. The power amplifier is a Class E power amplifier. This is very important because Class E has an efficiency of around 80 or 90%. And therefore you can get 5 watts with these 3 very cheap BS170 MOSFET transistors without any heatsink. Normally if you had Class C you'd need about that size of heatsink. This is another QRP Labs kit, 5 watts power amplifier. Class C, you need that about that size of heatsink. That would add volume to add area to the PCB, which would increase the costs. The heatsink is not cheap either, and it's heavy as well, so it would cost more for shipping. So it really reduces the cost to do Class E. Then there's a 7-element low-pass filter here, which provides very good harmonic attenuation, so it will satisfy all the regulations in any country, including the US and the FCC regulations. The supply voltage is connected here. There's reverse polarity protection in case you connect it in reverse. It won't damage anything. You can use a supply voltage between 7 and 16 volts. I recommend keeping it to about 15 volts, which will produce 5 watts output. With 12 volt supply, I measure around 3 to 3.5 watts output, and down at 7 volt supply it will drop just under 1 watt output. So the output power does depend on the supply voltage. In fact, I pushed it all the way up to 20 volts in testing and got almost 10 watts of output. I don't recommend that because you'll probably start toasting these transistors very quickly. There's a CW key shaping which reduces key clicks or even removes key clicks, and on the transmit side. On the receive side, this receiver uses a very high performance front end, the quadrature sampling detector, which you see here, which is also sometimes called a Taylor detector, is a direct conversion method receiver which produces an I and a Q output. This is used in many software-defined radios. But this is not a software-defined radio. This is an all-analog radio where an operational amplifier circuit here produces a phase shift network, a 90-degree audio phase shift network, and at the output of that you cancel out the unwanted sideband. When it's properly adjusted, you get 50 or 60 decibels of unwanted sideband cancellation, which is very, very good for a radio of this type. Then there's a 200 Hz CW filter here. This is based around a design by the Four States QRP Club, David Kripe NM0S, used with permission here. It's a very nice design that has no ringing and excellent performance and quite narrow 200 Hz. Now this is the display module. This is a 2-row by 16 character LCD module which is used for showing the frequency. So let me come to my powered up version here in front of us. This is a 20 meter version, and then you'll be able to see it in operation. Blue backlit on the LCD module. There's a rotary encoder here in the middle which is for tuning. The tuning is all synthesized. It's not the crystal which is pulled over a limited range. It's a synthesizer chip, the SI53518 you see here near the tip of my screwdriver. That produces 3 independent frequency outputs, 2 of which used for the quadrature sampling detector mixer, and the third one is used on transmit. So the synthesized VFO provides us a lot of flexibility, things we can do with the microcontroller, such as having the VFO-A, VFO-B, you can see the A or the B indicated here in the top left, and a split operation where we'll be receiving on the frequency, the A frequency, and transmitting on the B frequency. There's also RIT, receive incremental tuning, which you can adjust here. You can adjust the keyer speed, so this has a built-in CW keyer which supports iambic mode A, B and automatic mode, and it supports automatic character spacing if you wish, which is what was used in the old Ultimatic keyer from several decades ago. Here I'm using a Palm Radio Pico paddle. This is available from Palm Radio. Very nice paddle. But there's also a CW micro switch on the board which can be used as a keyer, as a straight key when you've got it enabled in straight key mode. On the left here, this knob is the gain control, and there are also 2 other buttons here which are used for the menu setting, as well as a button in the middle of the rotary encoder when you press the knob here. These buttons all have 3 functions depending on whether you do a single click or a double press or a long press, so you get 3 different functions, and that enables us to be able to reach the operations and functions of the radio that we use most often during a QSO without delving deeply into menus. The headphone output is here on the left, and I use standard earphones, just the ones that came with my mobile phone, and it works very well. On the right, as I mentioned before, that's the paddle input. You could also mount the controls off board if you wanted to, if you had a particular enclosure in mind that you wanted to use with it. There's also some simple digital signal processing included in the microcontroller, which allows us to do a CW decoder. You can use this on receive. Of course, no decoder is ever as good as the one in your head if you're good at decoding CW. Any machine decoded CW does require that the timing is quite accurate, and if there is QSB or QRM, it's never going to be as effective as the one between your ears, but nevertheless it can help if you're new to CW. Here you can see some of the errors in my own timing between characters and between words in the decoded Morse on a transmission in transmit mode. I tend to leave it on in transmit mode but off in receive mode. You can also use the key when you want to enter menu items, and it's quicker than just using the rotary encoder and buttons. There's also an S-meter which can be displayed up in the screen. The S-meter is a relative indication, it's not really a particularly accurate indication. And on the top right here you can have a battery icon which shows battery voltage. If you wish to use this for portable operations, that could be useful as well. Transmit receive switch is fully solid state, and that lets us use full QSK mode, which means you can hear the other station in between your own dits and dars, and in between the symbols and in between the characters of your Morse. Or you can use semi-QSK, which means it will stay in transmit mode and automatically switch back to receive mode after a short delay, rather than letting you hear the other station in between your own keying. When I press the left button here, it enters the menu system. There are quite a large number of menu items which control the functionality. There are 16 preset frequencies. This one I've got set to the whisper reception frequency on 20 meters I was listening to earlier. There are also 12 preset messages, so you can have automatic message transmission. So you could, for example, of course I've got nothing sensible in here at the moment, but you could set up a CQ message, for example, and transmit that on an automatic repeat cycle. You can control how many repeats and the interval between repeats as well. So that's an automated message sending if you wish to use that. The VFO has various settings associated with it. The keyer here, as I mentioned, you can have straight mode, iambic A, B, or automatic mode. I'll leave it in straight mode. Keyer speed. Keyer swap allows you to swap the DIT and the DAR connections in case your keyer uses a different standard than the one here. Some keyers, some paddles do, so that's quite a useful feature. Adjustable keyer weighting. Some people like to use a more hard keying where the timing is varied. Here you can control auto spacing on or off. Full QSK or semi QSK, and there's a practice mode as well, which allows you to transmit without actually emitting any RF. Sidetone frequency and sidetone volume are also configurable. The decoder allows you to set various parameters associated with digital signal processing. I won't discuss those in too much detail, but you can read the manual for more on that. Then, very importantly, there's a beacon mode. So the beacon mode will allow you to do a CW beacon or a whisper beacon. So that's quite an exciting use of the kit. If you're not using it as a CW transceiver, you can just use it as a whisper beacon. It supports connection of a GPS, such as the QRP Labs GPS kit, which I'm showing here. Very high sensitivity kit with a built-in patch antenna. So it supports connection of a GPS, which is quite important for whisper mode because it sets the time precisely and also calibrates the frequency precisely. Whisper requires precise frequency and timing. It will also set your locator, so that can be another useful feature. The other menus, various miscellaneous settings, but then the really exciting part, and which I really don't think has been seen on a kit of this type, is the alignment menu. Now, just a word about this. Often when you build a kit, you'll come to a section in the manual when you finish the assembly, and it will say, now turn on your signal generator because we're going to align the radio. Now, what if you don't have a signal generator? Well, it says where you can tune to a strong signal on the band. What if you don't find the strong signal if the band is closed, or if there's QRM or lots of fading? And so all of these, to me, that's really annoying when I reach that part in the manual, and that's usually where the kit which I'm constructing gets put on the shelf to be finished later, and sometimes spends a long time on the shelf. Well, here, all the test equipment and alignment equipment is built into the radio itself. So remember I mentioned the synthesizer has 3 channels. 2 control the receiver, and the third one controls the transmitter. The third channel can also be used as a signal generator and fed back in to the RF input. All of this happens on the board via an attenuator, all on the board internally itself, controlled by the firmware. And that allows you to inject a signal generator test frequency which can be used for aligning the radio. So let's look in here. You don't normally need to adjust these parameters. To adjust the bandpass filter, that's this trimmer here on the right hand side. When I enable this, it's now injecting a test signal. Now when I turn this, you'll see that the amplitude starts to drop off. It's using digital signal processing to display amplitude on the screen. Now when I come back, I go through a maximum and then it will start to drop off again. So peaking the bandpass filter is a very simple matter of tuning that trimmer until you get the peak. The next thing you do is inject a signal on the unwanted sideband. By the way, you should do this without the antenna connected because you don't need any additional inputs. You just want to use purely the injected signal without adding anything from the antenna. So I should have done that before. So, as I mentioned, this is a quadrature sampling detector that produces an I and a Q path output, and these have a different amplitude, slightly mismatching, and so the IQ balance control is used to match the amplitude, and it's this 24-turn trimmer potentiometer that you see here by the end of the screwdriver. Now, the signal generator is injecting here a signal on the unwanted sideband, the opposite sideband, and as I turn this screwdriver, you can see that the amplitude starts to increase. Now I want to minimize the unwanted sideband, so I want to adjust this for minimum. Now I turn it back and you see how it goes through a minimum point and then it starts increasing again on the other side. So it's very easy to find the place where the signal is minimum according to the measurement on the display, and then you know that you've got your I and Q channels balanced. The next thing we have to do is adjust the audio phase shift, and on the low audio and the high audio, this allows us to adjust the phase shift networks for 90 degrees, and then we get precise cancellation of the unwanted sideband. Now you go back and forth between these three a few times, and it will allow you to minimize the unwanted sideband. Using this, it's possible to get 50 or 60 dB of unwanted sideband cancellation within a matter of moments, all on board with no additional test equipment. So this is a really fascinating aspect of the kit, which is turning out to be a big bonus, because not everybody has lots of test equipment, not everybody has a nice lab, and this really makes it easy to set up. The other features in this alignment menu are calibration of the system frequency, the 20 MHz crystal that drives the processor, and the reference frequency, which is the 27 MHz frequency reference for the synthesizer chip. These can be automatically adjusted if you connect the GPS. As I mentioned earlier, that's used for Whisper. If you connect it, it will measure its own frequency, again internally on the board with no additional wiring, and it will allow you to set your transmit frequency precisely on frequency by adjusting that reference frequency of that crystal. So it's another part of the alignment. The GPS is not mandatory, but it's just a useful extra if you want to be able to do that calibration, and particularly useful if you want to be able to do Whisper transmissions. Finally, there's a lot of test equipment built in as well. There's a DVM here. One of the pins you see on this three-way header here allows you to use the screen here as a voltmeter, which can be used for debugging purposes. The manual control lists a set of voltages that should be found at each point in the circuit, and you can use that to test those. Later you can permanently jump it across to the battery voltage if you want to use the on-screen icon which shows battery voltage. It's a little icon that steps down just like the one on your mobile phone. Now there's also an RF power meter, one of the other pins on here. If you wish to connect a wire from here to the RF output, you'll be able to measure your RF power, assuming you've got a 50 ohm dummy load connected. Then there is also a frequency counter, a general purpose frequency counter that allows you to measure 0 to 8 MHz and could be useful for various things in your shack. And finally a signal generator, very wide range. It covers 3.5 kHz to 200 MHz, and for much of that range is producing two signals with a 90-degree phase offset. This signal generator has general purpose use in your shack if you want to use it for anything else. If you've got any radios left on the shelf which you haven't finished building the kit because you didn't align them, now you've got a signal generator to be able to align them. So these are some test equipment which are built in, and so add to the value of the kit. It's really, so in summary, you've got a very nice high performance radio. The quadrature sampling detector here has a really high dynamic range, high IP3, high sensitivity. The performance of the receiver will compete with the best of your commercial radios by Kenwood, ICOM, Yaesu, etc. The firmware on the processor can be updated when QRP Labs reduces enhancements. There's an in-circuit programmer header here. You can connect one of these $3 AVR programmers from eBay, and that will allow you to upgrade your firmware for free. So just to summarize, it's a very high performance radio with a lot of digital features built in at a very good price of $49. I think that nothing with this degree of performance and functionality has been seen before for maybe 3 times that price. So this is really a great opportunity and has so far proved to be very popular amongst constructors worldwide. People are starting to get on air with these and the feedback is very positive. So I hope you've enjoyed the video and this has given you a little bit more information about the QCX transceiver, $49, now available from QRP Labs. Thank you for watching. Bye bye.